Hello students, in this problem we are given two lines. Line L1 given in parametric form, line L2 is given in symmetric form, and we need to check whether these lines are parallel, intersecting or skew lines. Two lines are parallel when they have the same direction vectors. Two lines are intersecting when they doesn't have the same direction vector but they share a same common point. Two lines are skew lines when they doesn't have the same direction vector nor they share the same common point. Skew lines are those lines which never intersect each other and they lie in more than two dimensions. So let's see how to find the direction vectors of these given lines. When the lines are given in parametric form, then the constants attached with the parameter t represent the direction vector. So here the constant attached with parameter t are the 4, -3 and 1. Direction vector of line L1 is 4, -3 and 1. And the direction vector of line L2 is, when the line is given in symmetric form, then this is symmetric equation, then those denominators represent the direction vector. This 8, -6 and 2 represent the direction vector. Let's see whether they are the same. We can see 4 times 2, 8, -3 times 2, -6, 1 times 2, 2. So the second direction vector is the second multiple of first direction vector. That means is the second multiple of first direction vectors. So the lines are parallel when the direction vectors are same or they are the multiple of each other, then the lines are parallel. So we have checked that lines are parallel. Now we need to find the equation of a plane containing these two parallel lines. To find the equation of a plane, we need two things: normal vector and any point lying on that plane. To find normal vector, we need to find the cross product of two vectors lying on this plane. This is the plane. On this plane, these are two parallel lines, and L1, L2. These parallel lines have 2 points. Point P1, first line L1 is passing through point P1. Second line is passing through point P1. And this is the normal to this plane. This normal is orthogonal to this plane. To find normal vector, we need to find the cross product of two vectors. So one, we can use the direction vector of these two lines because they have the same direction vector, and other one we can find the direction vector of 2 points P1 and P2. So let us see where are these 2 points. This one, these numbers represent point through which this line is passing. So first point is 6, 4, -7, and second point is, when we find the point for the symmetric form, these signs get changed. This +1 gives us a -1, and this -1 becomes a plus, and this +5 becomes a -5. Let me show you how to change the symmetric form to parametric form. For that, we just set each part equals to parameter t and solve for x, gives us -1 plus 8t. Same way, when we solve it for y, we get y negative. Set the third part equals to parameter t and solve for z. We get x equals -1 plus 8, y equals 1 minus 6t, and z equals -5 plus 2. And you will see that these points, these numbers represent the point and their signs get changed. It gives us -1, 1, -5. So this is point P2. So either you can convert the symmetric form to parametric form and then write the point or you can just change the signs from here itself and write the second point. Now we find the direction vector by subtracting them. We get -1, -7 plus 5. This gives us 7, 3 and -2. This as second direction vector, and we already have this direction vector as 4, -3 and 1. You can also use a direction vector as 8, -6, 2, but it's good to write the one which is in simplest form. So we use 4, -3 and 1. Now we are going to find the cross product of these two vectors. So we are going to find the normal vector by finding the cross product of p dash and vector. Using the first row, we expand this determinant. I is written outside. We cross out these rows, the first row and the first column, and multiply these two numbers. Cross multiply them. So it's 3 times 1 is 3 minus -2 times -3 gives you 6. So it's 3 minus 6. Then j is written with a negative sign. Then you cross out these middle row and the first row. You are left with 7 times 1 is 7 minus 4 times -2 gives you -8. And for the last one, for k, eliminate this first row and the last column. Cross multiply these two numbers. 7 times -3 is -21 minus 4 times 3 is 12. 3i. This gives you 7 plus 8, 15, -15j and -33. This is the normal vector which we are going to use to find the equation of the plane. The formula for equation of the plane is the dot product of the normal vector and the components x minus x1, y minus y1, z minus z1. x1, y1, z1 are the point through which the lines are passing. You can choose any of the point from two lines. So normal vector is -3, -15. Let us choose the first point P1 as 6, 4, -7 as x1, y1, z1. So x minus 6, y minus 4 and z minus -7, which gives you z plus 7. Now write their dot product. So while finding the dot product, their respective components get multiplied. So -3 times x minus 6, 15 times y minus 4 times z plus 7 equals to 0. Simplify it further. Divide it by negative. This is the